Hi, I'm Sanat Maningi. Here's my physics extra credit assignment. So basically, we're doing the world's largest swing, and first things first, you gotta draw diagrams that looks nice, and figure things out. And we learned from the video it's 150 feet rope. And we learned that at the bottom, or when the rope catches, which is going to be at the bottom of the swing, you're 10 feet away from the ground, so it's about 160 feet is where you start from, which is the cliff. So that's your initial height, and initial height from the ground, and you know that your final height from the ground is about 10 feet. So before we start, our assumptions are there's no air resistance, the mass is going to be my mass, and that it's a frictionless pivot point. And then we use energy principle, and that's just going to be EF equals EI plus work, and work's 0 in this case, so EF equals EI. And then break that down into KF plus UF equals KI plus UI. And we know that initial velocity is 0 because that's when you start off. So Ki cancels out, and then we solve for Kf, and then solve for velocity, final velocity. And like I said before, Hi, your initial height is going to be 160 feet. Your final height is going to be 10 feet, and then I got a number around like 29.95 meters per second. So that's the speed at the bottom of the swing. And then we find tension, which should be F net perpendicular equals Ft minus Fg. And Ft is a tension force. So tension force equals gravitational force plus F net perpendicular. And F net perpendicular is mv squared over r. R is 150 feet because that's the rope's length. And then just solve, so I get like 2336.15 newtons. So that's tension force. And then for finding it 30 degrees away from the vertical, basically you just do the same exact thing to find the velocity, except this time your final height is equal to 30 feet because you're 30 feet away from the ground, and that was found by some trig right here, just like 30 degrees and whatnot. Cosine 30 equals h over 150, and then 150 times cosine 30. So find that, and then you find the force of tension, and force of tension this time is a little different because it's at an angle. Basically, you just plug it in the equation, and you get those numbers: 27.88 meters per second and 23.99 newtons. And then find if the rope was a spring. Basically, we set the spring constant at 29,000 because we found that online after some research. And then we know that the spring force is equal to the force of tension, which will be equal to Ks, and solve for S. And the force of tension at the bottom, we use the force of tension at the bottom of the swing, and the force of tension at 30 degrees. And then we got 0.08 meters stretch for the bottom of the swing, and 0.06 meters stretch at 30 degrees away. And then for the coding, basically using like the 3D Spring Lab stuff, we basically calculated a model simulation, and we put in the numbers for KS 29,000. I put my weight in, and then the 8 different H's, like 41.148, which is the starting position, calculated through K, and that's because it's the relaxed K of the rope. Anyway, calculated F net tangent, which basically change momentum over delta T times the unit vector for momentum, and then F net perp is just total net force minus F tangent. Then we ran it to check if it works out well for approximately 30 degrees away from the vertical, and we found out that it does, and those are the arrows. And yeah, that's that, and it prints out, and 27.59 meters per second is what they got, and that's what we got for 30 degrees away from the vertical. Yeah, that's it.